All right, so we're going to be looking at 6B, which deals with measures of variation. So there's two main things we're going to do tonight. We're going to learn how to make a box and whisker plot, and we're going to learn how to do standard deviation. Now, if you got the support course, I sent a video last night working the 6B support, and it was dealing with finding standard deviation and looking at stuff like that. So we're going to actually get into the MR part of this course for 6B. So first of all, we're going to look at what the range is. So the range of a data set is the difference between its highest value and its lowest value. So it's the difference between the highest value and the lowest value. Okay. All right, so a few more definitions and then we'll start making us some box plots. So now we're going to look at what we call quartiles. And quartiles is just splitting your data into 4 groups. Okay, you're going to split it into 4 groups. You're going to have a lower quartile, in the lower quartile, it's going to divide the lowest fourth of data points from the upper 3/4. So from the upper 3/4. So basically, it's going to be the lower fourth of that data. Now, we got a middle quartile. And y'all, these will make more sense when we start drawing a box plot of this data. But the middle quartile, and it can also be called the second quartile, just like the lower quartile can be called the first. So that could be the first quartile, and this one could be the second. It's the median. It's the median of the entire data set. And actually, something else we could say on the lower quartile, it's the median of the lower half of data. Okay, so the lower quartile, the median is the center of that lower half of the data, or the bottom half. The middle quartile is going to split it, and then we're going to have what we call an upper quartile. The upper quartile divides the lower 3/4 of data from the upper fourth. So from the upper fourth. And it's going to be the median of the upper half of the data. So it's the median of the upper half of data. So basically, I can find these quartiles by doing medians on them, okay? And then also, this upper quartile could be known as the third quartile. So, in order to draw a box and whisker plot, we're going to go by what they call the 5 number summary. And this is basically how we'll get the lines and stuff we're going to draw for the plot. And it's going to consist of the following numbers. You're going to have a low value. Then we're going to figure out our lower quartile. We'll figure out our median, our upper quartile, and then our high value. So I'm going to show you a picture of what this box plot is going to look like. So first, we'll have a line where the lower quartile is. I'll have a line where the upper quartile is, and then I'll know my median. These three, we box them in like a box. This is our median. This is the lower quartile. And over here will be our upper quartile. So this part they call it a box. And then what we'll have a line coming out with a horizontal line right there. This horizontal line will correspond to the high value. And then on the left side, we'll do the same thing. And we'll have a line that corresponds to the low value. So this is how we're going to make our box and whisker plot. See, it looks like a box, and it looks like it's got whiskers on it. So that's why they call it a box and whisker plot. Okay, so this next little example I'm going to show you is going to compare two banks in their waiting times, and we're going to make a box and whisker plot off of this data. So here we go. We're going to draw, and we'll just call it a box plot for each of the following. So they're giving me two banks and the times that people have to wait in line. So I got a big bank. So at big bank, people waited 4.1 seconds, 5.2, 5.6, 6.2, 6.7, and 7.2. Then I got a 7.7, 7.7, 8.5, 9.3, and finally 11.0. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points for big bank. And then we got best bank. In best bank, we're looking at 11 customers also. They had a 6.6, 6.7, 6.7, 6.9, 7.1, 7.2, 7.3, 7.4, 7.7, and then 7.8, 7.8. All right, y'all, so what they want us to do on this is create a box plot for each one of these. So we need 5 things. We need a low value, my lower quartile, my median. But remember, my median is also the second quartile on this. my upper quartile, and then I need my high value. So I got the low value. These are in numerical order here. So the low value for this one was 4.1, and the high value was 11.0. Now let's find the medians. So the whole data set had 11 data points. So when you got 11 data points, you want to find the exact middle one to be the median of the whole set. So since I got 11 points, 1, 2, 3, 4, 5, the 6th data point will be my median because I got 5 numbers before it and then 5 numbers after it. So the median on this is going to be 7.2. Now let's find the lower quartile. The lower quartile was the median of the 4.1 all the way to the 6.7. This is the lower half of the data points. So the median will be the middle number of this data set, because there's 5 of them. So the median will be 5.6, which means the lower quartile is 5.6. All right, upper quartile, we'll take the upper 5 data points, which is the upper half, and we find the median of them 5 points. Well, since there's 5 of them, the median will be the middle number because it's odd, and the middle number is 8.5. So I've got my data to draw my first box plot. So let's go over here to Best Bank and do the same thing. We'll find our low value, our lower quartile, our median, our upper quartile, and our high value. So we're given the low value, which was 6.6. The high value on this one was 7.8. All right, we had 11 data points again, so the median of the overall data set will be the 6th number again. So 1, 2, 3, 4, 5, 6. So my 6th number is a 7.2, so that's going to be my median of the whole data set. Then the lower quartile, I'll take the first 5 numbers and find their median, which will be the middle number of those 5. So the middle number is going to be the 6.7, so that'll be my lower quartile. And then remember, on the upper quartile, I'll take the median of the upper 5 numbers, or the upper half. So let's see, that'll be the middle number will be 7.7. So remember, we were looking at the time people were waiting in line at both of these banks, okay? All right, so now let's draw the first box plot. So I'm going to draw the box. And label these 3 points. I know the median was 7.2. The lower quartile was 5.6. The upper quartile was 8.5. And then let's draw our whiskers. So our whiskers are going to come off. My low value for the left whisker was 4.1. And then my high value for the second whisker was 11.0. Okay, now I'll draw the same thing for Best Bank. So I'm going to draw my box and my median. The median was also 7.2 for Best Bank. So that means both banks, overall, their average wait time was 7.2 seconds. So my lower quartile was 6.7. Upper quartile was 7.7. And then we'll draw our whiskers. Well, y'all, the whisker on this one only went out to 7.8. And then over here, the left whisker went to a 6.6. So if I wanted to know stuff like which bank might have had happier customers, and I know these are the waiting times in line, I might think that the best bank, since it had the same average wait time as the big bank, would be the happier customers, because it looks like the longest anybody waited in line at the best bank was 7.8 seconds. To where over here, you had a few slightly large waiting times at the 8.5 and up to the 11.0 even. So 11 seconds, they was probably a little angrier than someone that waited just 7.8, okay? So they'll have you look at data. Although they had the same average or means, more of the data from Best Bank was in between 6.6 and 7.8, to where Big Bank was from a 4.1 all the way to 11 seconds. All right, y'all, so then the second big thing of the day was standard deviation. And we really use standard deviation to describe how much, so, so it describes how much the data points vary from the mean. Right, so what's happening to my data points? Are they all close to the mean, or do I have data points spread out real far about my mean? So this standard deviation tells us on average how far from the mean our data points are, okay? So we're going to have a formula for standard deviation. So the standard deviation is going to equal the square root of the sum of the deviations from the mean. So all that's under that little radical. And then that is divided by the total number of data minus 1. So the total data points minus 1. And I'll show you symbols that I use on some of these. Sum, you can use a big fancy E, that means sum. So I'll sort of show y'all that. So I'm going to write the steps to work in this formula. So the steps to finding standard deviation. And y'all, I'll tell you what, if you take real statistics every one day, standard deviation is represented by that little symbol right there. So here's our steps. We're going to find the mean of the data. Then we're going to subtract that mean from every one of our data points. So subtract the mean from every data point. So that's when you hope you don't have a whole lot of data points, okay? Alrighty. So that could either give me a positive number or a negative number, depending on whether my points are higher than the mean or less than the mean. But what we do to that then, we square each of those results. So I'm going to square each one of my results, which means if you got a positive, when you square that, it's going to be positive. And when you square a negative, it also becomes a positive, because remember, a negative times a negative is a positive. Then I'm going to add up all the squares we just did. Once I've added all them up, so that's giving me this top part of that fraction now. Once I add all them squares up, then I'm going to divide by the number of data points minus 1. That's that data points minus 1. And then finally, to get the standard deviation, I'm going to take the square root of the above number. Once I take that square root, it's undoing all this stuff that I was squaring up. And once I take that square root, it'll tell me my standard deviation, or how far from my mean is most of my data going to be, okay? So let's see. So they got what they call the range rule of thumb. And this is just a shorthand way of finding it. But the range rule of thumb says that you can get approximates. So this is approximately standard deviation is equal to the range divided by 4. Now this is mainly true. It's a lot closer if your data don't have outliers on it. Way out there numbers, okay? If you don't have a lot of outliers, and this is actually pretty accurate, you can take the range, which is the largest number minus the smallest number, and divide by 4 to get your standard deviations. Also, the second part of this says that if you know the standard deviation of the data set, then we can estimate the high and low values. The low value is going to equal your mean minus 2 times your standard deviation. Your high value is going to equal your mean plus 2 times your standard deviation. So this is just a way to sort of estimate and approximate these. Remember, this is just approximations. They can get me close, but they might not be accurate. And if I had a lot of outliers, that could be way off, okay? But the true way to find it is going to be using this formula. All right, so I got a couple problems I want to work through here. So let me turn over and get my paper ready. So this first example, they're giving me East Coast counties. So I'm going to get data for an East Coast county. And I'm going to have data for Midwest counties. So East Coast counties, Midwest counties, okay? All right, so let me see what we got. These tables I'm about to write give the cost of living index for 6 East Coast counties and 6 Midwest counties. So using an index where 100 represents the average cost of living for all participating cities within a population of more than 1.5 million, we're going to answer parts A through E below. Alrighty, so let me write the counties down. They had County A had 104.7, B had 128.3, C 314.7, D 134.5, E 123.1, and then F 141.9. So that's my 6 East Coast counties. Now my Midwest counties, I had U 96.8, V 92.8, W 94.7. So we're not really worried about the letters. They're just using them to represent the different counties. We're mainly worried about these numbers I'm putting. X is 87.4. Y is 95.2. And Z is 228.1. So here's what they want us to do first. They want us to find the mean, median, and range for each county. So first, for A, I'm going to find the mean, median, and range for each counties. So I'll do the East Coast counties first and then the Midwest counties. So for the East Coast, and then over here will be our, Midwest. So we're going to find the mean first. So the mean, and we'll be wanting to use our calculators for this, but the mean, I'm going to add all these scores up and then divide by 6 because that's how many I had. So to add all these scores up, we'll have 104.7 plus 128.3 plus the 314.7 plus the 134.5 plus 123.1 plus 141.9. When I add all that together, that's going to give me 947.2. I'm going to divide that by 1, 2, 3, 4, 5, 6. And let's see, 947.2 divided by 6. Now let's see, they want me to 2 decimal places as needed. So I got a 157 point, that's going to be an 8. So I'm looking at the 6th round. Since that's a 6 after, that 6 will round to a 7, so I'm going to have an 87. Now, the median. So let's see. My numbers are not in order, so to find the median, remember my data has to be in order. So the lowest number is 104.7. What's next? 123.1. 128.3. Oh, what's next? 134.5. 141.9. And then finally I had 314.7. So now this is an even number of data points. So to find the median, you got to take the 2 most inner data points add them together, and divide by 2. So 128.3 plus 134.5 is going to equal 262.8. And since I added 2 points together, I divide by 2. So 262.8 divided by 2 gives me 131.4. So that's my median. And then what was the last thing I needed? My range. The range is the difference between the highest data point and the lowest data point. So since I put them in order here, my highest data point is 314.7 minus my smallest data point, which is 104.7. So let's see what we get. 314.7 minus 104.7 is going to give me, what is that, 210. So that means my range from 104, if you added 210, you would get up here to the 314.7. So that's how wide my data is on that. And, all right, guess what? I got to do all that now for Midwest. So Midwest, to find the mean, we're going to add all these numbers up and divide by 6. So we got 96.8 plus 92.8 plus 94.7 plus 87.4 plus 95.2 plus 228.1. That total gives me 695. I need to divide that by 6 also, so divide that by 6 to get an average of 115 point. So let's see, 2 decimals, so that's going to be an 8. So I'm rounding to where the 3 is. Since that's a 3 after, I'm going to leave that a 3. So I get 115.83. Alrighty, median. Once again, for the median, I need my numbers in order. So let's see, my smallest number is 87.4. Then I got a 92.8, 94.7, 95.2, 96.8, and finally 228.1. So remember, the median is going to be the 2 innermost. I'm going to add them together and divide by 2. So 94.7, what I got, a plus, what's that, 95.2? That's going to equal 190.2, but remember, we got to divide by 2 because my median can't be higher than my data points, okay? All right, let's see what we get. We get a 95.1. Now, finally, we got to get the range. So the range is going to be the difference of the highest number minus the smallest number. So that's going to be 228.1 minus 87.4. And I can round 2 decimal places if needed. So 228.1 minus 87.4 gives me a range of 140.7. All right, y'all, so I'm going to let y'all catch up because we're about to do the quartile stuff to it. So I'm going to give y'all a second to write that. I guess this class is for the ones of y'all that like doing math type work where you got to do calculations instead of the theory stuff we've been doing. Now we want to keep this data handy for part B here. Part B wants me to give the 5-finger summary for each. So give the 5 number. So the 5 number summary for each. So remember, that meant my low value, my median, and my high value. But then they also want to know the lower quartile and the upper quartile. So first I'm going to do, what we got first? How about East Coast? So this is East Coast. So East Coast data, we know the low value because we got it right here. Their low value was a 104.7. The median, well, we found the median. The median was 131.4. We know the high value, that was 314.7. So what we got to do now is find that lower quartile and the upper quartile. So, y'all ready? So what I got to do here is find the median between these 2 points and then the median over here that's in between this half of the data. So I got to look at this lower half of data first. So I got 3 points over here. So since I got 3 points, that median will be the middle point for the lower quartile, which will be 123.1. All right, let me let one in real quick. Now, to get the upper quartile, that's going to be the upper half of the data, and there's 3 points on the upper half of data, so its median is going to be the middle number, which is the 141.9. All right, y'all, so let me let y'all write that real quick because I'm going to have to turn my paper over. All right, y'all ready? All right, so let me do the same thing for my Midwest counties. So Midwest counties. All right, so I'm going to find my low value, my median, my high value, my lower quartile, and my upper quartile. All right, so let me do one thing, get my numbers ready for me real quick. All right, y'all ready? So we had the low value they gave us. We put them in order. That was what, an 87.4. We found that median to be 95.1. Our high value on that data was the 228.1. So let me put this down here because we're going to find our lower and upper quartiles off of this data. So here's my lower half of data. Its median will be the middle number, which is 92.8. So 92.8 is my lower quartile, And then my upper quartile is the upper half, and its median is the 96.8. All righty, let's see. Then it looks like they was making box plots out of that. So just remember the box plots, your lower quartile, upper quartile, and median will be the box. So your median is going to be the 95.1. Lower quartile was the 92.8. Upper quartile, 96.8. And then your whiskers will come out. Over here's the lower value was 87.4. And then the high value was 228.1. So that's what they was having you do this data, so you can make you a little box real quick of it. Alrighty, so here comes the work. Now, this is part C. We're going to find the standard deviations of each. And then that looks like the last thing they want us to do to this is find the standard deviations of each. So, let me get my data back out here. So, we already know the mean. So, we're going to do East Coast right here. So, East Coast and then Midwest. We know the mean of each of these because we done found it a while ago. So the mean of East Coast we said was 157.87. The mean of Midwest was 115.83. So y'all, let me show you what I do to find standard deviations. I take each of my data points, I'm going to write them down in the line. So I had, and they don't have to be in order, so I'm going to go 104.7, 128.3. So I'm just writing the 6 numbers down. 314.7, 134.5, 123.1, and then 141.9. So these are all the numbers. Then what we're going to do is take each of these x's minus the mean we found. Then we'll take all those answers and square them. Okay, so we're going to first take all these x's minus 157.87 and make this row. So 104.7. Let me turn it on. 104.7 minus the mean, which is 157.87. That's going to give us a negative 53.17. Now, if you want to go on and square that real quick, hit the x squared button on the calculator, and it'll automatically square that answer into a 2827.0489. So I'm just going to keep my decimals for a little bit. All right, next, we take the 128.3 minus 157.87. So we're doing that for this second row. That's a negative 29.57. Square that, and we get 874.3849. Same thing here. 314.7 minus 157.87. That one's going to give me 156.83. When I square that, I get 24,595.6489. Whoa, some of these are big. All right, 134.5 minus the 157.87 is going to give us a negative 23.37. Square that, I get 546.1569. All right, two more to go, y'all. So 123.1 minus 157.87 is going to give me negative 34.77. Square that, and I'm just hitting that X squared button to square them. What is that? 1208.9529. And then finally, y'all, 141.9 minus 157.87 is going to give me a negative 15.97. Square that, I get 255.0409. All right, so what you want to do under this last row, you want to add all of these up, because this is going to be the sum of all my x minus my mean squared, okay? So let's add this row up. 2827.0489 plus 874.3849 plus 24,595.6489 plus 546.1569 plus the 1208.9529 plus my last one, 255.0409. Now, I always keep a lot of digits, but y'all probably could have shortened that down to 2 digits if you wanted to and pretty much got the same answer. But when I add all them up, I get 30,307.2334. So a little over 30,000. So remember, my formula for standard deviation was the square root of my sum of all my numbers, which is the 30,307, divided by n minus 1. So let's think. What's the total number of data points I had? I had 1, 2, 3, 4, 5, 6. So this will basically be 6 minus 1, which is 5. All right, so let me bring my paper down just a little bit right there. So we're going to divide that and then take the square root of it, okay? So 30,307.2334 divided by 5. Remember, that's always going to be the total number. So n equaled 6 for this because we had 6 data points. So that had to be 6 minus 1, okay? So divide that by 5. That's going to give me a square root of 6061.44668. So my final answer will be the square root of that number. So remember, to do the square root, you hit the second button. The x squared button brings up a radical, 6061.44668. So all that's under that radical, and I think they wanted me to round this like 2 decimal places. So let's see, when we hit enter, I get 77 point. So let's see, since that's a 5, I'm going to round that to a 6. So that'll be 0.86. So that is our standard deviation. But y'all notice we got some semi-low and some semi-high values on that, okay? All right, same thing over here. We're going to write all of our x's, our x minus our mean, and then x minus the mean squared. We'll add all them up, get the sum, and then we'll find out that standard deviation. So y'all, that one I had 96.8, 92.8, 94.7, 87.4, 95.2, and 228.1. So first we got to take this and subtract 115.83 since that was the mean of this second data. So 96.8 minus 115.83 is going to give me a negative 19.03. I'm going to square that and get 362.1409. 92.8 minus 115.83 is going to give me a negative 23.03. Square that, and we get 530.3809. All right, 94.7 minus my mean, so 94.7 minus 115.83 is a negative 21.13. Square that, and I get a 446.4769. All right, so 3 more to go. 87.4, whoops, minus 115.83 is going to give me a negative 28.43. And y'all, watch how I'm doing this. So some of these homework questions are going to ask you, how do you find these squares? And that's because we're subtracting the mean from our data points, okay? All right, let's square that, and I get 808.2649. 95.2 minus 115.83 is going to give me negative 20.63. Square that, I'm going to get a 425.5969, and then finally 228.1 minus 115.83 is going to give me a 112.27. Square that, and I get 12,604.5529. Woo, you got some big numbers when you carry out these decimals. But next, I need the sum, so I'm going to add that row together to get my number. So let me put this right here. So I got 362.1409 plus 530.3809 plus 446.4767, whoops, 4769, plus 808.2649 plus 425.5969. Woo, finally, plus 12604.5529. All right, when I hit enter, I'll have all those added together, and that is 15,177.4134. So now to get that standard deviation, it's the square root of the 15177.4134 divided by 5 again, because I had 6 data points, 1, 2, 3, 4, 5, 6, and 6 minus 1 is 5. So y'all watch how I do this all in one problem. I'm going to hit my radical, which is second x squared, And I'm just going to put this whole thing in it. 15177.4134 divided by 5. So that's all under that radical. So when I hit enter, I will have my final answer. So if you want to do it by steps, you would take that and divide by 5, and then take that answer and find the square root. But if you want to do it all at one time, just put all of this under that radical. Now, we'll say this. If you got older calculators, it's going to do like this and put a parenthesis. You got to put 15177.4134 divided by 5 and then close parentheses. So if you don't have the new one where it puts it underneath and it gives you a parenthesis, you got to put everything in and then close those parentheses, okay? Woo, getting tongue-tied, but here we go. Hit enter to get that final answer of 55. We're going 2 decimal places. So that 9 has a 5 after it. So it looks like that needs to be a 1, 0. So it's going to kick that 9 up, which turns that 0 into a 1 and makes that 9 a 0. All right, so notice the standard deviation wasn't as high for the Midwest as it was for the East Coast. That means that the Midwest data, the mean, more of the data is closer to the mean than versus the East Coast. Because look here, the East Coast had some 314s and some 104s. Over here, most of this data is pretty much right in the same area, other than that one outlier. And if it wasn't for that one outlier, this would have even been a lot less standard deviation, okay? So y'all, let's see. That looks like the big problem I wanted to get out of here. So I wanted y'all to see how I made those box and whisker plots. And I wanted y'all to see me doing standard deviation. So if you do want more examples of me doing standard deviation, look at that support video I sent last night, because I'm pretty sure that 2 of them problems, the 3rd and the 4th, were nothing but finding standard deviations, okay? All right, so here's my thing. Tuesday night, we'll do more lectures, but I'm going to I'll be back on campus. So I'll have my face-to-face Tuesday night, and I'm going to do live Zoom the same night. I think they're getting that fixed where we can do that good now. And I want to see how y'all are doing on that project on Tuesday night. So for the weekend at least, you want to have your car picked, and you want to know what loan you might go with, okay? All righty, also, any questions? All right, so if there's no questions, y'all have this video. I'm going to send it out later as soon as I can get it uploaded. And you have my video last night from the support. So if there's nothing else, I will see y'all